So this is a second video on this section. We're going to pick up right where we left off. We so far graphed the parent graph. This is the most basic U-shaped curve parabola that you're going to see in this whole chapter. All other parabolas ultimately are just a transformation of this original parent graph parabola. Let's continue down here. We're going to go over the vocab words that we already went through. Vertex, the most important point. It's simply a coordinate. What is a coordinate? It's an XY value. It's either the highest point or the lowest point of your parabola, depending on whether it opens up or down. So we already know that. We already know that if the A value is positive, it opens up. If the A value is negative, it opens down. And of course, if it opens up, then your vertex can be called the minimum. And of course, if it opens down, your vertex could be called the maximum. Let me just give you an example of that. If I take a ball, let's say this is a red ball right here, and I throw it up in the air, it's going to reach a max height, and then it's going to come back down, correct? So this parabola, if I throw the ball, it actually it travels in the path of a parabola. So if I throw this ball, it's going to go up, and at some point it's going to reach a maxed height, and then it's going to come back down. So of course, if my parabola opens down, then the vertex will be a max value. Does that make sense? Okay. And let's also talk about a minimum value. Let's say you're bungee jumping, right? Let's say you're this red dot, and let's say you bungee jump and you're falling, and then all of a sudden you bounce back up, right? Falling, bounce back up. That is also the path of a parabola, bouncing back up. So if you do go down and then bounce back up, well, it's more like a little U-shaped curve at the bottom. That's disgusting. That was a bad example. Let me erase that. The point that I wanted to make here is if your parabola opens up, then you'll have your vertex being a minimum value. Okay? Anyway, let's jump back to the notes. Again, the vertex, the most important point, it's also the maximum value or the minimum value, depending on whether it opens up or down. Now here is a very, 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 very important formula when it comes to the vertex. Now remember, we said the vertex was a coordinate. What's a coordinate? It's just the x and a y value, right? Yay? Okay. And this formula, you're going to have to memorize it. This formula right here. What is the formula? X equals negative b over 2a. Okay? So you're going to use this formula. You're going to say x equals negative b, which you don't know, over 2 times a, which you don't know. So where are you going to get the a and the b values from? You're going to get them from the standard form quadratic trinomial equation. So your a value's here, your b value's there. The formula doesn't even have a c value. So you're going to go negative b over 2 times a. So you're going to get your numbers from here, from the a and the b spot, and you're going to plug them into right here and here, the b value here and the a value here. And then you're going to be able to do the math. And guess what? That's going to be your x value of your coordinate of your vertex. Now, once you have the x value, all you have to do is plug it back into the original to find the y. Now, that might sound a little confusing because we don't even have an actual example. Let's check out the top right-hand part of these notes. It says, remember, the vertex is actually a coordinate. This formula will only give you the x value of your coordinate. You still need to plug it in to find your y value. Okay? So finding the vertex is pretty easy. Not only that, the axis of symmetry, we already talked about the axis of symmetry. The axis of symmetry is that green line that divides a parabola perfectly in half that goes right through the vertex. Now, the line of the axis of symmetry, since it's always going to be vertical, it's going to be x equals a certain value. X equals a certain value. In this case, it's x equals 0 because my dotted line of the axis of symmetry goes right through the x value of 0. But the truth is, the formula for the axis of symmetry is going to be the same exact formula for the vertex. So that's right. This formula for the axis of symmetry is the same exact formula for the x value of the vertex. Now that makes total sense. It does. Because the axis of symmetry goes right through the vertex. That's why it's the same formula. Are you guys with me? I hope so. Please don't be falling asleep. Whoops. Let's move this up. So we have some steps that we're going to follow, and it looks confusing, but honestly, it's easy. It's just like riding a bike. You got to get the hang of it. You got to practice, and it becomes easier the more you practice. So step one, it says find the vertex using the vertex formula. And then, of course, once you get an answer for x, you plug it in to x to solve for y. After that, step two, draw your axis of symmetry. It's just drawing a vertical line right through that vertex. Step three, plug in some numbers with an xy table. And it does say on the same side of the axis of symmetry, on the same side of your vertex. That'll help you when it comes to saving time, because if you put them on the same side, you're going to be able to reflect them to the other side of the axis of symmetry and label the coordinates. And then you draw your parabola through the points. So it looks like confusing four-step process, but it's pretty simple. Let's start with step one. We have an equation down here. Step one says to find the vertex. So keep in mind, the vertex, I'm just going to put a V right here. The vertex is going to be a coordinate, an x value and a y value. Agree? And we're going to use the vertex formula, x equals negative b over 2a, to find the x value of the vertex. So this is what I'm going to start with. X is going to equal negative b over 2 times a. Now, I'm going to use that formula, but I need to write my letters as parentheses. So I'm going to say x equals negative parenthesis over 2 times parenthesis. So what is my b value that belongs up here? Look at your b value over here. What's my b value from this standard form quadratic trinomial equation? What's my b value? 6, thank you. So let's plug in a 6 for b. What's my a value on your standard form quadratic trinomial? Negative 3, thank you. So put a negative 3 down here for the a value. So what do I really have? I have negative 6 over what? Negative 6, correct? So I really have x equals negative 6 over negative 6. Ladies and gentlemen, what is that? That's 1. So x equals 1. Now, what are we talking about here? Remember, this gives us the x value of our vertex. So we just said x is 1. So I want to put the 1 right here. So my x value of my vertex is 1. So anytime you have an x value and you want your y value, what do you have to do? Anytime you have your x value and you want your y value, what do you have to do? You substitute. You plug it in. Plug it in where? Take this one, put it right here in this x, and take this one and put it right there in that x. And then do the math. You with me? So the safe thing to do would be to rewrite this, but instead of x's, put parentheses. So let me zoom in and rewrite everything, but instead of x's, put parentheses. And what am I plugging in? The x value of what? 1. Thank you. So we have the 1 right in there. Let's do the math. Of course, you're going to use order of operations. 1 squared is 1. So you really have negative 3 times 1. That's just negative 3, correct? How about 6 times 1? What's that? That's just 6. Bring down the plus 5, and you should be able to find out your y value right there. After all, it says y equals, what does y equal? What's negative 3 plus 6? That's 3. What's 3 plus 5? 8, right? So the final answer is 8. So my y value is 8. So my y value of my vertex is 8. So ladies and gentlemen, I have my vertex, 1, 8. That was step 1. That's the most important point of a parabola, because that's the center of the parabola. That's the point that the axis of symmetry is going to go right through it. Does that make sense? So let's graph the vertex 1, 8. Now let me first make this graph a little nicer by putting some lines on the x-axis and the y-axis. So what was the vertex again? 1, 8. So if I go 1 on the x, 8 on the y, I'll be right there. Let me do my vertex in red. There's the coordinate 1, 8. Are you with me? That was step 1. What's step 2? Looking at the notes right above, what's step 2? After you draw your vertex. Axis of symmetry. So I'm going to zoom in right to my vertex, and I'm going to draw the axis of symmetry. I'm going to draw it as a dotted line, and it's going to be vertical, going right through that vertex. That's my axis of symmetry. I'm going to make it all the way through this graph, all the way down right through it. Okay, it's kind of ugly, I apologize. But anyways, that is your axis of symmetry. That's going to save you a lot of time and a lot of work. So now, what I want to do is go to an XY table. I need some coordinates. So let me go to an XY table. And let's plug in some values. Give me an easy number to plug in. Which is the easiest number to plug in?
1.
Even easier than 1. 0. Check it out. If I plug in 0 into the original, what's 0 squared? 0. What's negative 3 times 0? It's 0. 6 times 0 is 0. 0 plus 0 is 0. 0 plus 5? 5. So ladies and gentlemen, when I plug in 0, I get out a 5. Let me actually put that coordinate on the graph. 0, 1, 2, 3, 4, 5. That's right here. Are you with me? Now, since we know the axis of symmetry is right through the vertex, the highest point in this case, I could reflect it over to the other side, and that's just, notice that that point is 1 unit away from the axis of symmetry. It's 1 unit away, so I'm going to go 1 unit this way and put a dot right there. Does that make sense? So far, my parabola is this. Now, of course, we need more points. So I need to plug in more values into my XY table. What would be another nice number to plug in? You might think 1, right? You might think, I'm going to plug in a 1. But guess what? You already plugged in a 1. Where? On the vertex. Remember, you found out that the x was 1 and you plugged in a 1, you got out an 8. So if you plug in a 1 again, you're going to be wasting your time. You're going to get an 8, and it's going to be the same coordinate right here. Would it be smart to plug in a 2? Would it be smart to plug in a 2? No. You know why? Because if you plug in a 2, I mean, yeah, you can plug it in and do the math, but guess what answer you're going to get? You're going to get 5 as an answer. Now, how do I know that? Because I already reflected it over here. So if I did go 2 on the x and 5 on the y, that's where I'd end up. Does that make sense? So it'd be a waste of time to plug in 2 because you're going to get 5 anyway. So since you plugged in 0, you might as well plug in either -1, or if you want, you could plug in +3. I always say plug in values that are on the same side of the vertex, on the same side of the axis of symmetry. So let's plug in something like -1, okay? And let me zoom in to the actual function up here, and let me rewrite it, but instead of x's, put parentheses, and I'm going to put a -1 in there. So there's my function. Let me plug in a -1 right in there. And if I do this correctly, -1 squared, that's +1, and -3 times +1 is -3, and 6 times -1, that is -7, and the +5 just comes down. So when I plug in the -1, I actually get -3 minus 7 plus 5. And that answer is going to be what? -3 minus 7 is -10. -10 plus 5 is what? -5. So when I plug in a -1, I get out a -5. Okay? So let's actually graph that point, -1, -5. So from the origin, we're going to go -1, -1, 2, 3, 4, 5 right there. That is a big, ugly dot. I apologize. But anyway, we know that the axis of symmetry runs right through the vertex, so I could just map it over. If it's 2 units away from that axis of symmetry, 2 units away will be right here. And now we could just extend the parabola and put some arrows on it. Extend the parabola and put some arrows on it, and we're done. We graphed the parabola. And that's it. That's how to graph. Of course, we're going to do more videos, and we're going to work on this for many days. Don't freak out if you don't get this yet. I hope this video helps. There's obviously not enough time to do this last one. We're going to pick it up on this one on the next video.